You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome in, everyone. You know, the pace of modern tech, especially infrastructure, it's relentless, isn't it? Decisions you made like 6 months ago, suddenly they're being rewritten in Rust or maybe handed off to an AI agent. And that speed, that constant change, that's really why we're here. We try to cut through all that noise, the releases, the fixes, the big architectural shifts, and just give you the stuff you actually need to know about. Uh, I'm really excited to get into the material today. Like we do every week here on The Vocal Technologist, we're aiming to make the complex make sense, focusing on what's really driving things forward in DevOps and infrastructure.
Yeah, and today we're looking at, I think, two really massive themes that are kind of crashing into each other. First, there's this reality check happening with AI infrastructure. It's getting more mature, sure, but also surprisingly fragile in some ways.
Fragile, interesting.
Yeah. And the second theme is that constant push for, raw speed and stability in our core systems. We're seeing languages optimized, sometimes completely replaced, all trying to get us closer to systems that can, well, manage themselves. The goal is really stability, speed, and genuine automation.
Okay, let's start with that reality check then, because I think a lot of us assume that these huge companies running the big AI models, they've got the infrastructure totally locked down, right? Flawless. But the details we have suggest even the giants are wrestling with some pretty basic, almost human infrastructure problems.
Oh, absolutely. It's probably the most surprising thing we saw this week. We got some insight from Anthropic about how their Claude models were seeing some intermittent dips in quality. This was back in late summer, early fall.
And it wasn't like an algorithm problem or bad training data.
Nope.
Yeah.
It was the plumbing. They actually tracked it down to not one, but 3 separate distinct infrastructure bugs. Think about that. Really subtle issues deep in the system, but they were affecting the quality and the reliability of the AI's output. And it wasn't just on one cloud either. These bugs popped up across different versions of Claude running on AWS Trainium, NVIDIA GPUs, and Google TPUs.
Okay, that tells you something right there. Even with these huge multi-cloud setups, just getting basic, consistent quality control across platforms, it's a struggle. They're deploying the AI so fast, maybe the underlying stability checks haven't quite kept up. Anthropic basically had to promise much stronger evaluations moving forward.
And this leads to a kind of tension, doesn't it? Because at the exact same time we're finding and fixing these really fundamental reliability bugs, the whole industry is sprinting towards the next thing, Agentic AI.
Right. That's the big buzzword. If the models themselves can be this, well, shaky sometimes, how do we build autonomous systems on top of them?
Agentic AI, just for anyone maybe not deep in it, is where software stops just following scripts. It starts to, perceive its environment, reason about problems, and actually do things autonomously.
Software acting more like an employee.
Exactly. And guess what platform is emerging as the foundation needed to manage these sort of digital employees? It's Kubernetes.
Of course.
Leveraged heavily through platform engineering principles. You see providers like Google with GKE. They're specifically tuning their managed Kubernetes to handle these AI workloads in production. They're trying to build a solid house for these potentially quite volatile new agents.
Which means the tools managing the infrastructure, they need to get smarter too. They almost need to become agents themselves, right? Which is kind of meta, AI managing the systems that run AI.
It is. And that automation layer, it's coming online fast. Take Pulumi Neo, for instance. Pulumi is embedding an AI-powered agent right into its cloud platform.
Yeah.
Neo's whole job is automating infrastructure tasks, provisioning, managing, optimizing, but crucially, while also making sure governance and compliance rules are followed. And the really clever part, it learns from your existing infrastructure as code. So it gets better at managing your specific setup over time.
So Neo is like your AI infrastructure buddy, keeping things running smoothly and by the rules. We're seeing similar ideas around securing data access for these agents too, right? Like what Slack's doing.
Yeah, the Slack Model Context Protocol, or MCP Server, that's really important for security.
Oh, so?
Well, it provides a framework so these AI agents can securely access sensitive, customer-owned conversational data without exposing it. The AI gets the context it needs from your private chats to make better decisions, but the data stays locked down. It's about enabling the agent safely.
Okay, got it. So we've got this AI maturity issue, the rise of agentic platforms built often on Kubernetes, and new AI tools emerging to manage the complexity. Now, let's shift gears a bit. Let's go deeper, maybe under the hood, to where the raw speed and stability battles are being fought.
Yeah, let's talk Cloudflare. because the news about their FL2 system, their new core traffic management system, that's a massive win for performance architecture.
They rewrote their core traffic system in Rust. And the numbers they reported, I mean, they're not small improvements, are they?
Not at all. They're claiming a 25% performance boost,
25%.
a full 10 millisecond reduction in latency, and CPU and memory usage cut by more than half.
Wow.
And a big part of that is Rust itself, right?
Mm-hmm.
Its memory safety guarantees just eliminate whole categories of nasty bugs. That's critical when you're talking about a system handling a huge chunk of the internet's traffic. This new system, FL2, is set to replace the old one completely by early 2026.
That's a huge success story for Rust. But what's really interesting is at the same time Cloudflare's proving Rust's power, they were also digging into the stability of, well, more established languages, like Go.
They were indeed. And they uncovered something pretty scary, a really subtle, hard-to-find race condition bug, deep inside the Go compiler itself, specifically the ARM64 compiler.
Whoa, a compiler bug. That's the kind of thing that gives engineers nightmares because it potentially affects everything built with it. What is it actually doing?
It was causing random, unpredictable crashes, panics on ARM64 machines, all traced back to stack corruption.
Stack corruption? How?
It happened during asynchronous preemption.
Yeah.
Basically, the system gets interrupted, right? And if that interruption happened at the exact wrong moment during garbage collection when the stack pointer was being adjusted, boom. The system could pull the rug out from under itself, essentially.
Yikes. That sounds incredibly difficult to debug.
Oh, absolutely. Sporadic, architecture-specific. Yeah. And the fix is super precise. They had to ensure the stack pointer is always valid. So now they build the offset in a temporary register first and then add it to the stack pointer in one single atomic instruction. Can't be interrupted. This fix is in Go 1.2, 3.1, or in later.
It just goes to show, doesn't it? No matter how mature a language or tool chain is, you need constant, deep vigilance. Finding something like that in the Go compiler.
Exactly. If the compiler itself, the thing meant to create reliable code, can hide a bug like that for who knows how long. It just underscores why robust tooling, observability, everything. It's non-negotiable.
And that is the perfect lead-in to talking about tooling. Because all this complexity, AI, multi-cloud, different languages, subtle bugs, it demands serious tools to manage it, especially when you think about the cost when things go wrong.
Yeah, there's that Commodore report we saw, put a number on it. IT teams are spending, on average, 34 workdays a year just putting out fires, just resolving incidents.
34 days. That's almost 7 weeks of lost productivity. Just gone.
And apparently, nearly 80% of those incidents link directly back to a recent change made to the system.
That 34-day number, that's the why behind so much of platform engineering right now. Troubleshooting is just eating up time. It's why you see platforms like New Relic Control becoming generally available.
And New Relic Control is aimed squarely at that problem.
Right.
Trying to tame the chaos. Precisely. It's about giving teams a unified control plane for observability. Centralizing and automating how you manage telemetry metrics, logs, traces across everything. Kubernetes clusters, regular hosts, doesn't matter. The idea is consistency, control, reducing the variables that lead to spending those 34 days firefighting.
Makes sense. And drilling into Kubernetes itself, since that's where so many changes happen, we're seeing shifts in how scaling works too.
Big time. The move from the traditional cluster autoscaler to Carpenter, especially with the recent v.32 migration guide, is really about getting faster and smarter.
How so?
Carpenter uses concepts like node pool and EC2 node class. It's designed to react much faster to scaling needs and be more intelligent about using different instance types, especially spot instances. So you get faster scaling and potentially lower cloud costs, plus better resilience. It's optimizing that core Kubernetes function.
So better tools to prevent the fires and better tools to handle the scaling demands that might cause fires.
That's the idea. And it's not just complex systems. Even simpler tech is getting more robust. Look at SQLite. Lightstream, the backup tool for it, just hit v0.5.0.
Okay.
And they're refocusing on the core backup model, but adding point-in-time recovery PITR using a new file format called LTX. This is a big deal because it opens the door to things like instantly hydrating read replicas from backups. It makes SQLite, which is super simple and fast, genuinely viable for more mission-critical, resilient applications, taking the simple tools and making them enterprise-ready.
That drive for stability and resilience, it's also showing up in how major open source projects are governed, isn't it?
Yes, definitely. The biggest news on that front is probably the new React Foundation.
Ah, hosted by the Linux Foundation.
Right. React and React Native, I mean, these are cornerstone technologies for front-end development. They're moving to this independent foundation for community-driven governance. Meta's still involved, providing significant funding. But the key is that React's future isn't solely tied to one company's priorities anymore. That provides long-term stability for the huge ecosystem that depends on it.
That's a smart move for the community. Okay, one last area before we wrap up. Infrastructure as code. We've got tools like Terraform for provisioning, Ansible for configuration, but getting them to work together smoothly, especially across different clouds or hybrid setups, that can still be messy.
Oh, it can be a real headache.
Yeah.
Which is why the tighter integration between Terraform and Ansible using these new Terraform actions is pretty significant.
What does that actually let you do?
It lets you build unified workflows. So Terraform can provision a resource, say a VM in AWS or Azure, or even on-prem, and then immediately trigger an Ansible playbook to configure it correctly.
Okay, so it connects the build it step with the set it up step automatically.
Exactly. It helps ensure consistency. When Terraform spins something up, Ansible instantly knows what state it should be in. This helps maintain accurate inventories across complex environments and seriously cuts down on configuration drift. It basically stops that infrastructure sprawl problem where things get out of sync.
That sounds incredibly useful for teams juggling hybrid cloud. Okay, so, wow, we've covered a lot of ground here. AI fragility, Rust adoption, compiler bugs, platform engineering tools, governance shifts, IAC integration. What's the big picture takeaway for folks listening?
Well, I think we're seeing the industry grappling with the teething problems of large-scale AI infrastructure. Those Anthropic bugs are proof. At the same time, there are these huge wins in foundational performance, like Cloudflare hitting that 25% boost with Rust. But maybe the most strategic threat is this massive push towards platform engineering. Tools like Pulumi Neo, New Relic Control, Carpenter, they're all aiming to automate away the sheer complexity that's currently costing teams, 34 workdays a year in firefighting? Automation isn't just nice to have anymore. It's becoming critical for survival.
Yeah, that 34 days figure really sticks with you. And my closing thought kind of builds on that automation theme, that convergence of AI and infrastructure. We're actively building these really sophisticated AI agents, right? Pulumi Neo, those Slack MCP agents, designed specifically to monitor and manage infrastructure. But these agents themselves run on the infrastructure. Infrastructure that, as Anthropic showed, can still have subtle flaws. So here's the question, the thing maybe to chew on. We saw how subtle that Go compiler race condition was, lurking in mature code for years. As we start letting AI agents autonomously write, provision, and manage our core infrastructure, what entirely new classes of weird, unpredictable, super hard-to-find bugs are we potentially creating?
That's a good question. If the AI is managing the stack that the AI itself runs on, talk about a complex feedback loop. Debugging that's going to be interesting. We'll need ways to verify the verifier, so to speak.
Absolutely. Something to keep an eye on. Well, thank you for joining us today as we unpacked all this material. There's always more going on beneath the surface.
Spoken Tech for your ears.